In the words of G.H. Hardy, a mathematician like a painter or a poet, he is a maker of patterns. If his patterns are more permanent than theirs, it is because they are made with ideas. Now let us know trigonometric functions and each trigonometric function domain and range. First of all, let theta belongs to real number set R. Take an angle measure theta in its standard position. I am taking x-axis, horizontal reference line is called x-axis, vertical reference line is called y-axis. Intersecting point of x-axis and y-axis is called origin O. Here, angle at x I will show it 0, y is pi by 2, y is pi by 2 radian. At x dash 0, pi by 2, next pi radian, pi by 2 plus pi by 2. Pi plus pi by 2, 3 pi by 2 radian, 3 pi by 2 plus pi by 2, that is 2 pi radian. We call these are the quadrant angles. If the terminal side in standard position, if the terminal side coincide with axis, then that angle is quadrant angle. Here it is 0 degree. Here at 0 radian, pi by 2 radian, that is 90 degree, pi radian, that is 180 degree, next 3 pi by 2 radian, 270 degree, 2 pi radian, that is 360 degree. I am taking an angle theta in its standard position. Take an angle theta in its standard position. And take a point P xy on terminal side. I am taking initial side as OA and terminal side as OB. Take a point PXY on terminal side. Based on this, we can define trigonometric functions. Let theta belongs to R, and where take theta, angle measure theta in its standard position. Take any point PXY on terminal side. Such that length of OP as R, OP is equal to R greater than 0. OP is equal to R greater than 0. Here OP has the radius, R has the radius. I am drawing a circle. Draw a perpendicular from P to the positive x-axis OX, so that let me take foot of the perpendicular as Q. In this case, distance from x-axis to a point is y coordinate, distance from y-axis to a point is x coordinate, here to here x, so that their perpendicular distance x. We know trigonometric functions we write like this, we define like this. Trigonometric functions are we call ratios. Ratio of y coordinate and ratio of y coordinate of any point on terminal side and distance from origin to that point. That ratio is called sine of that angle. So y by r is called sine of angle theta. Y by r is called sine of angle theta. Y coordinate, ratio of y coordinate and distance from origin to the point. Otherwise we can write in a right angle triangle opposite side to theta by hypotenuse. That is sine of that angle. Next, x coordinate by r is called cosine theta. X by r, ratio of x coordinate and r is called cosine theta. Cosine of the angle theta. Ratio of y coordinate and x coordinate is called tangent theta. First of all, based on right angle triangle, we can say adjacent side to theta by hypotenuse is called cosine theta. We write as cos theta. X by r is called cosine of the angle theta. Here, ratio of y coordinate and x coordinate, y by x is called tangent theta. Y by x is called tangent theta. Tangent of the angle theta. Next, we based on right angle triangle, we can say opposite side to theta by adjacent side to theta is called tangent theta. Next, it is reciprocals. R by y coordinate, R by y is called ratio of distance from origin to the point P, and y coordinate is called cosecant theta. R by y is called cosecant theta of angle theta, cosecant of theta. Next, r by x. R by x, that means distance from origin to the point, ratio of the distance from origin to the point and x coordinate. R by x is called secant theta. Secant of theta. Next, secant theta. X by y, that is ratio of x coordinate and y coordinate, is called cotangent theta. X by y is called cotangent theta. Here, ratio of x coordinate and y coordinate are a ratio of adjacent side and adjacent side to theta and opposite side to theta. We define as cotangent theta. We based on point we can define, otherwise based on right angle triangle. Defining based on the point on terminal side, we can extend these trigonometric ratios for not only for acute angles, for other angles also we can extend, so that when terminal side is in second quadrant or third quadrant or fourth quadrant, we can extend these trigonometric ratios using this concept for other angles also. When theta belongs to R and the angle measured theta is in radians, we define trigonometric functions as y by r is sin theta. Y by r is called sin theta. X by r is called cos theta. Next, y by x is called tangent theta. Tan theta. Next, r by y is called cosecant theta. R by y is called cosecant theta. Next, r by x is called secant theta. Next, x by y is called cot theta. Now let us know the domain and the range of these trigonometric functions clearly. It is very clear that sin theta and cos theta are defined. Sin theta, cos theta. As sin theta is y by r, cos theta is y by r, as r is the constant for this pxy. For pxy, r is constant. Sin theta and cos theta are defined for any real value of this angle theta. Sin theta, cos theta are defined for any theta belongs to real numbers at r. So domain of sin theta is r. Domain of cos theta is real numbers at r. Now let us see domain of remaining trigonometric ratios. Here I am taking tan theta. Tan theta is equal to y by x and secant theta is r by x. For the both denominator is x. If x is 0, tan theta is undefined. If x is 0, secant theta is undefined. Tan theta and secant theta are defined only when x not equal to 0. Tan theta, secant theta are defined only when theta x not equal to 0. Only when x not equal to 0. If x is 0, tan theta, secant theta are not defined. When x gets 0, this x, when it gets 0, if q coincide with o, then x gets 0. When q coincide with o, if the terminal side coincide with y-axis, then q coincides with o, then x becomes 0. So at that case, angle is pi by 2 or 3 pi by 2. So to coincide OP terminal side with y-axis, theta value either pi by 2 or 3 pi by 2 or 5 pi by 2 like that. That means in that case x becomes 0. So pi by 2, 3 pi by 2, 5 pi by 2 and so on. That means 2n plus 1 pi by 2. In case of 2n plus 1 pi by 2, this terminal side coincides with y-axis. In that case x value 0. So that in the condition tan theta and secant theta are undefined. Let us write the point. Tan theta comma secant theta are not defined, are not defined. Tan theta comma secant theta are not defined at theta is equal to 2n plus 1 pi by 2, where n belongs to z. We give n plus 0, that is pi by 2. If you give n plus 1, 3 pi by 2. In the angles, theta value, tan theta, secant theta, both undefined. So that domain of tan theta and secant theta is other than 2n plus 1 pi by 2 values. That is about domain of tan theta and secant theta. Domain of tan theta and secant theta is r minus 2n plus 1 pi by 2, where n belongs to z. It is about domain of tan theta and secant theta. Let us see one more. Cot theta and cosecant theta. Cot theta and cosecant theta. Cot theta is x by y, cosecant theta is r by y. When cot theta denominator is y, as cosecant theta denominator is y, if y value is 0, in that case cot theta and cosecant theta both undefined. We can write cot theta comma cosecant theta are defined when y not equal to 0. In that case only cot theta and cosecant theta are defined. Cot theta and cosecant theta are defined when y not equal to 0. Why? Because cot theta is equal to x by y, cosecant theta is r by x, r by y. Here y should not be equal to 0. When y value becomes 0, OP, if OP leans on x-axis, then y value becomes 0. When OP coincide with OX, when theta is equal to 0 degree or pi radian, 0 radian or pi radian or 2 pi radian or 3 pi or 4 pi or 5 pi. If theta is equal to n pi, where n belongs to z, in that case the terminal side coincides with x-axis, so that y value becomes 0. In that case cot theta and cosecant theta are undefined. Cot theta comma cosecant theta are not defined when theta is equal to n pi, where n belongs to z. Here I am writing pi. If units are not mentioned, we have to consider as radian measure and pi radians. If units of the angle is not mentioned, at that case we need to treat that angle in radian measure. Okay. Theta is equal to n pi, n belongs to z. In that case cot theta, cosecant theta are not defined. So the domain of cos theta and cot theta and cosecant theta, we can take theta value other than n pi. Here r minus n pi, here n belongs to z. R minus n pi, n belongs to z. It is the domain of cot theta and cosecant theta. This is about trigonometric ratios and their domain. Sin theta domain is R. Cos theta domain is R. Real numbers at R. Tan theta domain. Tan theta comma secant theta domain R minus 2n plus 1. 2n plus 1 pi by 2. Here n belongs to Z. It is the domain of tan theta and secant theta. Cot theta and cosecant theta domain is R minus n pi and belongs to Z. Now let us know range of these trigonometric functions. In real numbers we know modulus definitions. Modulus x less than or equal to a. Solution minus a less than or equal to x less than or equal to a. Mod x less than or equal to a solution minus a less than or equal to x less than or equal to a. One more, mod x greater than or equal to a solution x less than or equal to minus a or x greater than or equal to a. We are well known with these formulae. Let us use these formulae to find range of trigonometric functions. See, in triangle OQP, I am applying Pythagoras theorem. In triangle OQP by Pythagoras theorem. By Pythagoras theorem, we know side square plus side square is equal to hypotenuse square. X square plus y square is equal to r square. X square plus y square is equal to r square. You know, in right angle triangle, hypotenuse is the largest side compared to the remaining two sides. So, it is very clear r is greater than x and r is greater than y. We can write mod x less than modulus x less than or equal to r and modulus y less than or equal to r. X is smaller than r, y also smaller than r. Modulus x less than or equal to r and modulus y less than or equal to r. Modulus x less than or equal to r. Modulus x less than or equal to a solution minus a less than or equal to x less than or equal to a. We can apply before that. Modulus x less than or equal to r I am writing as r into 1. Modulus y less than or equal to r we can write as r into 1. If we divide with r, we get modulus x by r less than or equal to 1. Here also if we divide with r, modulus y less than or equal to by r less than or equal to 1 divided with r. Now modulus I am writing for the both modulus x by r less than or equal to 1. Here modulus y by r less than or equal to 1. Modulus x less than or equal to a solution minus a less than or equal to x less than or equal to a. So x, what is 1 by x by r? X by r is nothing but cos theta. X coordinate by r is nothing but cos theta. In place of x by r, we can write cos theta. Cos theta modulus cos theta less than or equal to 1. Mod x less than or equal to a solution minus a less than or equal to x less than or equal to a. So that minus 1 less than or equal to x by r less than or equal to 1. Minus 1 less than or equal to x by r less than or equal to 1. Here modulus x less than or equal to a solution minus a less than or equal to x less than or equal to a. So that minus 1 less than or equal to y by r less than or equal to 1. Minus 1 less than or equal to x by r is nothing but cos theta. Minus 1 less than or equal to cos theta less than or equal to 1. And y by r is nothing but sin theta. Minus 1 less than or equal to sin theta less than or equal to 1. So from this we can come to know cos theta value lies between minus 1 and 1. And cos theta takes either 1, cos theta takes the value either 1 or minus 1 are the real number between minus 1 and 1. So cos theta, we can write range of cos theta, as minus 1 less than or equal to cos theta less than or equal to 1, or range of cos theta as minus 1 1. That means close bracket minus 1 1 means theta takes cos theta takes the value either minus 1 or 1, or the real number between minus 1 and 1. This is the range of cos theta. Come to sin theta. Sin theta takes the value either 1 or minus 1, or the value lying between minus 1 and 1. So range of sin theta. Range of sin theta we can write as minus 1 close bracket minus 1 1. It means sin theta takes the value either minus 1 or 1, or the real number between minus 1 and 1 for any real value of theta. It is about a range of trigonometric functions sin theta and cos theta. Now let us see range of cosecant theta and secant theta. X square plus y square is equal to r square, so that modulus x less than or equal to r, so that modulus x by r less than or equal to 1, and modulus y by r less than or equal to 1. If you take reciprocal, then what happens? R by x, modulus r by x greater than or equal to 1. If we take reciprocal, modulus r by y greater than or equal to 1. We know modulus x greater than or equal to solution, x less than or equal to minus a, or x greater than or equal to a. If we use that, r by x greater than or equal to 1, r by x less than or equal to minus 1, or r by x greater than or equal to 1. Here mod x greater than or equal to a solution, x less than or equal to minus a, or x greater than or equal to a. So that according to definition of absolute value, r by y less than or equal to minus 1, or r by y greater than or equal to 1. Here what I meant by r by y? R by y is nothing but definition of cosecant theta. R by y, that is cosecant theta. That is cosecant theta less than or equal to minus 1, or r by y nothing but cosecant theta greater than or equal to 1. In the same way, r by x is nothing but secant theta. That is definition of secant theta. R by x, hypotenuse by adjacent side of it. R by distance from origin to the point by x coordinate. That is secant theta. Secant theta less than or equal to minus 1, or secant theta greater than or equal to 1. So from this we came to know that cosecant theta value less than or equal to minus 1, or cosecant theta value greater than or equal to 1. So that cosecant theta value less than minus 1 or greater than 1. So that cosecant theta is not taking the value between minus 1 and 1. So that we can write a range of cosecant theta is like this. Range of cosecant theta as minus 1 minus infinity, close bracket and open bracket, union minus 1 and plus real value less than minus 1, and 1 and more than 1. That means 1 close bracket 1 no open open, infinite open bracket. That means cosecant theta takes the value real number minus 1 or the real number less than minus 1, and real 1 or the real number more than 1. It is the range of cosecant theta. The same way secant theta. Let us see secant theta. Secant theta takes the value less than minus 1. That means minus 1 or the real number less than minus 1, minus infinite. Union. Secant theta takes 1 or more than 1. That means close the bracket 1 and open bracket infinite. It means secant theta takes the value 1 or the real number more than 1. It is a range of secant theta. Range of secant theta. It is about range of cosecant theta and the range of secant theta. Now let us see a range of tan theta and cot theta. According to definition, tan theta is equal to y by x and cot theta is x by y. Y coordinate, x coordinate is tan theta. Ratio of x coordinate and y coordinate is cot theta. If x is non-zero and y, if x is not non-zero, if x not equal to 0, then tan theta, that means then tan theta is a real number. If x is not non-zero, then tan theta is a real number. Okay. If y not equal to 0, then cot theta is a real number. So tan theta range is a real number set R. Cot theta range is real number set R. This is about range of trigonometric functions: tan theta, cot theta, sin theta, cos theta, cosecant theta, and secant theta. Now let us write domain and range of different trigonometric ratios. Trigonometric function. The trigonometric function domain, finally it's the trigonometric function range. Let us write this. First of all, sin theta. Sin theta. Theta takes as sin theta is y by r. Sin theta takes any real number. Theta belongs to r. Sin theta maximum value is 1, minimum value is minus 1. Sin theta takes the value between minus 1 or 1 or value between minus 1 and 1. Range is minus 1, 1. Next, cos theta. Cos theta, theta takes any real number r. So, cos theta, sin cos theta domain is r. And range, cos theta maximum value 1, minimum value minus 1. Cos theta takes the value either minus 1 or 1 or the real number between minus 1 and 1. This is the range of cos theta. Tan theta. Tan theta takes the tan theta is not defined when theta is equal to 2n plus 1 pi by 2. So we can take theta value any real number other than 2n plus 1 pi by 2 Here n belongs to Z. We can give theta value any real number other than 2n plus 1 pi by 2. That means domain is r minus 2n plus 1 pi by 2 and belongs to Z. Then range of tan theta is any real number r. Get a real number. Next, finally, secant theta. Secant theta is its domain. Its domain also as secant tan theta is y by x. Secant theta value also r by x. So that it is not defined at 2n plus 1 pi by 2. So 2n plus 1 pi by 2 and belongs to Z. So domain of secant theta is r minus 2n plus 1 pi by 2 and belongs to Z. Here we get the range. Minus 1, open bracket minus infinity, close bracket minus 1, union, close bracket 1, infinite, open bracket infinite. That means secant theta doesn't give the value between minus 1 and 1. We get the real number other than the value from minus 1 to 1. There is a range of secant theta. Next, cot theta. Cot theta domain. Cot theta is nothing but x by y when y is 0. If it is n pi, so domain of cot theta is r minus n pi and belongs to Z. Range of cot theta is r, any real number. Finally, cosecant theta. Cosecant theta, it is also its value is y r by y. So it is not defined at y is equal to 0. So that domain of cosecant theta also r minus n pi and belongs to Z. It is the domain of cosecant theta. Let us see its range. Its range like secant theta minus 1 minus infinity, close bracket minus 1 open bracket minus infinity, union 1 infinity open bracket. That means it takes any real number other than the value between minus 1 and 1. 1 or more than 1, minus 1 or less than minus 1. That is the value of cosecant theta. We get the in that range. So these are the domains and range of different trigonometric ratios. Let us see sin theta, domain is r, range is close bracket minus 1 1. Cos theta, domain is r and range is minus 1 less than or equal to cos theta less than or equal to 1. Tan theta, domain is r minus set of 2n plus 1 pi by 2 and belongs to Z. Range is r. Secant theta, domain is r minus 2n set of 2n plus 1 pi by 2 and belongs to Z. And range is minus infinity minus 1 close bracket minus 1 union 1 close bracket 1 infinity open bracket. That means secant theta is less than or equal to minus 1 or greater than or equal to 1. Cot theta, domain is r minus set of n pi and belongs to Z. Range is cot theta, range is r. Cosecant theta, domain is r minus set of n pi and belongs to Z. Range is cosecant theta less than or equal to minus 1 or cosecant theta greater than or equal to 1. This is about domain and the range of different trigonometric functions.